Welcome to Pandoras Box video tutorials. In this lesson we want to show how to do infrared ID tracking in order to control a layer within Pandoras Box. So let's start with the general requirements for the IR ID tracking. First, we need some infrared cameras. For the IR ID tracking, Widget Designer supports only OptiTrack cameras from natural point. There are several models available, for example the Flex 13 that is powered by USB or the Prime 17 that is powered over Ethernet. In our tutorial we will use the Prime 13, also powered over Ethernet. To connect the cameras to a computer, please use only hardware that is recommended on the OptiTrack website, which lists network switches, USB hubs and cables. Further, we need IR ID tags provided by Kulux. There are single ID tags and quad ID tags available. Both emit infrared light and blink according to their ID. Software-sided, you will need the Widget Designer Pro or, in case you like to set up a separated network for the tracking data, the Ultimate version. Also, the Kulux USB driver is required for the tags and, when using the OptiTrack USB cameras, the OptiTrack camera SDK as well. Please be aware that there are several influences that can affect the usage of your tracking system, as for example reflections, pyro, fog or confetti. Also, the distance between the camera and the tags is important. And of course, there should be no movement on the position where you mount your cameras. There are a lot of parameters that are not explicitly explained in this tutorial, as it would go beyond the scope of this video. Therefore, please find more detailed explanations in our help file. Please understand this as a map of how to set up a tracking system that always needs more efforts to make it perfect in every detail. In our first lesson, we start with 2D tracking. Therefore, we need one camera and a minimum of one ID tag, plus the Widget Designer Pro and a Pandoras Box player version. One important information regarding the position data we will receive: in the 2D mode, Widget Designer will always output the position in 2 dimensions, which are called X and Y. This is independent from the camera position, meaning that it is not important how you install the camera. First possible scenario: it can be either mounted above the tracking area looking down, so that the tracked object can move left, right and front, back, but not change its height. Another possible scenario is that the camera is mounted in front of the stage, so that the tracked object can move left, right and up, down, but this time it cannot move front, back. In both scenarios, Widget Designer interprets the movement as X and Y movement. So after launching the Widget Designer, we open the node ID Tag Tracker. This will ask us to enable the OptiTrack Camera Manager within the Connection Manager, as it is required for using the ID Tag Tracker node. So here we choose Yes, as well as for the initialization of the OptiTrack cameras. Once we've done this, we see that our camera is already identified with its serial number. We make it active. Choose the grayscale mode while the IR filter is still disabled and increase the value for the exposure. Now you should see a grayscale picture which you can use to adjust the position and focus of your camera. After that, we decrease the value of the exposure again, enable the IR filter and go to the segment mode. There is a very important interaction between the exposure, the threshold and the chosen brightness of your ID tags. The exposure determines how many microseconds the lens shutter is open for light to pass through it and expose the image. The threshold sets the minimum brightness a pixel from the grayscale image must have in order to be considered as a valid pixel. Valid pixels are displayed in the segment mode as pink pixels and are potential tags. Additionally, the brightness of an ID tag, which you can change within the ID tag configuration, affects to this interaction as well. Since we already turned our IR ID tag on, it will be displayed when it enters the area our camera covers. Now, choose the tracking mode and connect your ID tag via USB to your computer. In the node, scroll down to the ID tag setting and click on Config ID tag. In case that you are using a quad ID tag, you have to do this configuration via the connection manager. In the ID configuration, you have to choose the mode which defines the maximum number of IDs you want to use in your whole setup. We have one tag, so we set the maximum to 4, as this is the smallest range. The ID is transmitted via a certain blinking. The interval describes how fast the above described blinking pattern is transmitted. The higher the frame rate of your camera, the shorter the interval you can choose. As a rule of thumb, USB cameras can see a 40 millisecond interval, whilst Ethernet models can go down to 20 milliseconds. Then you have to define the ID for this tag, which power source it should use, the number of active LEDs on this tag, and the brightness of the IR and blue LEDs. Finally, you have to save these settings to the ID tag. So, scroll up to the global tracking settings, where we choose 2D tracking and adopt the values of the ID tag referring to mode and interval. Now, the cameras look in the same mode as the tags are sending. Moving the tag into the tracked area will now show the tag with the selected ID. To output this data, you have to add multiple tags within the ID tag settings into the list. After we've done that, we connect an output info node to the ID tag tracker, which shows us the value of our ID tag. As you can see, we already receive X and Y values. To now move a layer within Pandora's box, we need to translate the maximum vertical and horizontal values of the area we want to work with via a range node to values we are working with in Pandora's box. Send this data to a layer control node. Ensure that the connection to Pandora's box is set up, and here we are. If you don't get a proper result on the first attempt, depending on, for example, different cameras or circumstances, you may work with some of the parameters that are not explained in this tutorial in detail. You will find many more informations in our help file. In the next lesson, we will go one step further and set up a 2.5D tracking. Have fun and thank you for listening.